Right, so yeah, I have one question. This is a problem from one of sample test. Find the exact length of the curve Okay, so this is given by the equation, okay? And the x is between 0 and between 1 and 2. Now, we don't need to sketch the graph, okay? So, yeah, the length is given by this formula, the integral. This is the most general formula, okay? And what you have to do is, s is arc length, okay? So you have to write down what is ds, right? ds is going to be, in this case, y equals f of x. So we will use this formula to evaluate the integral. So you end up with the integral x from 1 to 2, and then you differentiate, okay? When you differentiate x squared, you get 2x, it's 1 over x. Then here's 1 over x. It's a squared dx. Right? I'm going to look at what he did here. So far it's correct, okay? Now, when you square it, yeah, you got it right, okay? So when you square it, you don't need to simplify, just put 4x here, square, and minus twice of 4, a quarter of x times 1 of x. So that will be 1/2, then plus this. Okay. So you will is this 2 combined? So you change the sign, right? Plus 1/2 and here. Then you recognize that, okay, this is still, you can put back, it's quarter of x plus 1 of x squared, and therefore you can get rid of the square root, right? And so you can quarter of x plus 1 of x dx. Then the entire derivative will be 1 over 8x squared plus natural log of x. You put absolute value here. We're not sure, x is positive or negative. Then that's it. And then the number, of course, is pretty straight. Okay, so you get so natural log of 1 is 0. All you have to do is get 4 minus 1 is 3. 3 raised plus natural log of 2. It's a positive number, right? And so you did okay. You did good. Okay, since only one student's online, okay, do you have any questions? You can submit, I can discuss, but I don't have the sample final exam here. You have to tell me what it is, okay? So without getting any problems from you guys, let me ask you to do the following problem, okay? It's gonna be 1 plus 1 minus, okay? 1 minus 1 over x and 3x. All right, so let's try to do this problem. Okay, there are a couple ways to do. One is you can use a well-known result. We know that x is approach infinity, you will get 1 plus 1 of x to the power x is going to be p. You can use this result to solve the problem. Yeah, that you can use that only when x is positive over there. So probably cannot use this. Okay, let's use the same idea. So this is a 2 of x, 3 of x, right? How do you find the limit? You have to put e natural log, right? Then you take 3x down, right? Then you can get the, I'm going to leave 3 here on the side and put 1 of x there. So you can change the variable. 1 of x can let u to be 1 of x, right? So you can get 3 u natural log of 1 minus 2u. Okay, when u approaches 0, so x approaches infinity is same as u approaches 0 from positive side. So this will be 0, 0 type. And so the limit as u approaches 0, this is going to be use a L'Hopital's rule. It's going to be 1 minus 2u negative 2. Okay? So the limit is negative 2 when x approaches 0, when u approaches 0. So the final answer here is 1 minus 2 of x, 3x, e to the 3, right? Let me copy this. This approaches e to the 3, and then the limit of the limit is negative 2. So the answer is e to the negative 6. Well, if I ask you to do this, I think the only difference, yeah, this will be the limit. Yeah, the same, the limit is going to be eta plus e to the 6 as x approaches positive infinity. But you can do that using, you don't need to use an e here. You can write in the following form. Okay, it's going to be 1 plus 1 over u. Okay, so let's u equals to be x over 2. Okay, so then 2 of x is 1 over u. And then x is going to be 2u, so 6u here. Okay, so the limit inside is going to be e, outside 6, as u approaches infinity. So you don't need to go through the above procedure, just to use the already known result. Okay. How to find the derivative point, the inverse, the derivative of the inverse. I know this is I figured out this adapter problem. Another connection. This adapter is very hot. So something is burning inside. Okay. Yeah, I already burned all 2 adapters. I have one in my office. All right, find the derivative of this. Well, f of x is going to be x cubed minus x plus 3. All right. I assume that x is greater than 0. No, let me see. Assume that x is greater than 1. No, okay, sure. So I have to, let me change it because this is not necessary to have a, put a sign, positive sign here. Then it's okay. All right. So this one is the increasing function. It is always, it has an inverse function. Why? Because when you differentiate, look at it, when you differentiate, it's 3x squared plus 1. It's always positive. It's increasing. So the inverse exists, but you cannot solve it. Right? If I ask you to find the derivative inverse function at the 3, first of all, you should observe that f0 is going to be 3. That's simple observation. So that implies the inverse function has a value. Right? The value of the inverse function of 3 is going to be 0. Right? Right, so we did some preparation here. So then you have to write down the formula for the derivative of the inverse function. So now that's going to be 0. But we already found the derivative. The derivative is going to be 3x squared plus 1. So that's 3 times 0 plus 1 times 0. Taylor series. Yeah. Taylor series, I said that if you know how to find the easy way to find the Taylor series, then you can get 10 points. Taylor series, 12 points for each problem, I think. This time Taylor series is going to be a bonus problem, yes. Yeah, bonus problem. Okay. I know. Let me just look at. So what's your problem? Yeah, we are pretty similar to the bonus problem. Okay, so if we're able to do this, then you should. Okay, find find the Taylor series for the function. Okay, the function is 7 minus 3x at a equals 3. Okay, you don't well, you have to determine the radius of convergence of this this Taylor series, but let's find the Taylor series. Okay, now Taylor series by definition is going to be this one. Okay, but very few people can find the general formula for the answer or the derivative. Okay, so if you only give me a few terms, like a first term, second term, it's not good enough. You have to write down the general formula. So we do not use this unless it's a brand new function. Like, I'm trying to find a Taylor series for sine x, cosine x. We never learned that before. Then you have to use this original definition. So now we can use a known result, but be careful when you do the computation. Okay, I know that when I was grading the exam, I find that some students got the idea but cannot make it. So idea is you want to expand the power series in Taylor series. You know, if we can find a power series representation, that must be Taylor series. Okay, or it's sufficient to find the power series representation for the function at the 3. Okay, yeah. And actually more than what we asked for the function f of x at a equals 3. So let's do this, right? So you want to express in this form. So let u to be x minus 3. Let u to be x minus 3. So then x is going to be u plus 3. Be careful about the confusion. Okay? So f of x is going to be 7 minus 3x, right? 7 minus 2x. Okay, so that's going to be minus 2. X is going to be u plus 3. Great. So 7, be careful with it, right? When you work 2u minus 6. So the answer is 1 minus 2u. The simplified version. Now, maybe it's not 1 minus, maybe 3 minus 2u. Then you have to take 3 out, okay? So right now it's okay, perfect. You compare to this one, 1 minus, x equals, right? And x is less than 1. So you can use this to, so it's the first one is already 1 there, the 1 minus 2u. So x is going to be 2u. So that's why f of x is going to be sigma. And 2u to the nth power, and the negative 2u should be less than 1. Right? So my final answer will be 2 to the n. U is x minus 3 to the power n. Then x minus 3 should be less than 1/2. That's the radius. 1/2 is the radius of convergence. Okay. Right. So I'm going to ask you to do the following problem. This is the Taylor series already. Once it's power series, the function equals that, and then for x, in that interval, then this is a Taylor series already. Oh. Sorry about that. I was so focused on the power connections. Okay. Still not stable. Anyway, let's go on. Yeah. All right. So I'm going to ask you to find the Taylor series for the following function. I'll give you a minute to complete. Okay. For the function f of x equals, and I just 5 minus 2x. Okay. And this is going to be 1. Okay. At a equals 6. No, not 6. No, I use a different number. Yeah, 7. Okay. That's it. Please do this problem. Are you done? Okay. Right, let's do it. So step 1, let u to be x minus 7. Then x is u plus 7. So you have to put into the function. So f of x equals 5 minus 2u plus 7. Then you simplify it. 5 minus 2u minus 14. Okay, great. So you get negative, it's negative 9. Okay. You have to express as like a 1 minus something. So negative 9 is that, right? You take negative 9 out. So you will get 1 plus 2u over 9. Okay. So in order to use that formula, you have to put a negative 2u over 9 here, minus. So then you have finally, you take negative sign out and to the end minus the end. And u to them is x minus the power. We do get a power series representation. That's 3. And that should be the Taylor series. Okay. So of course you have to move the constant inside. Okay, it's negative. Negative 1 times n, 1 negative 1 to the n is n minus 1. And here's 9 n plus 1 to the power n, x minus 3. So this should be the final. Okay, let me ask you to work on this. So the math of radioactive material. Okay, it reduced to the 10% of the origin. 10% to of the origin. Right, and original quantity let's assume that in 100 years. Okay. All right, what is the half-life? I use the calculator. All right, I'll give you expression in terms of log. Huh? 50 years? Plus one. You want to do a shortcut? Please, I don't think so. Okay, so first of all, we have the general formula. We don't need to go through. Yeah, this is a P L A E to the KT. It's decreasing. K is negative. You can put a negative sign in front of the K, then K becomes positive. Okay, so this is a decreasing. Now, in 100 years, I want to determine the K. In 100 years, the material is reduced to 10% original. 10% is 1 over K of the original. E to the 100. Okay. So the initial quantity is used. It's not needed. Okay. So now if you put the H log on both sides, right, you will get 100K. So my K is going to be 1 over 100, and H log 1 over K. All right, so this is our K. Then for the half-life, you just put a 1/2 equals there, and E to the K capital T. So half-life is determined by that. It's reduced to the half. Okay. So the same story, you can put nature log E to the KT is given K times T. So all I have to do is just solve for T and divide by K, right? Right? What is K? K here is going to be 1 over 100, nature log 1 over 10. Yes, you can express in this form nature log 2 over nature log 10. The reason is nature log 1/2 is going to be negative nature log 2. So the negative sign will be cancelled out. So this is answer. It's not going to be the integer, right? Yeah, in some cases it's going to be integer, but this particular problem is not. Any questions?
some more chapter 11 stuff.
Chapter 11 stuff.
Like the,
Convergence, divergence. Okay. So I will ask you to look at this. This is n squared plus 1 and sine n squared plus 1. So tell me whether this is a convergent or divergent. Are you done? Convergent or divergent? You think? Yeah, usually when you see a problem, I can tell immediately this is convergent, divergent. You don't need to check, okay? But you have to give a correct argument to prove, we call it instinct, right? You see, I see it, this is convergent. There's a reason, how do you see that? Xn squared plus 1 there. N squared plus 1. It's like a P series, right? P series, when P is greater than 1, it's convergent. Now, how about the numerator? Does the numerator change a lot? No. Okay, so numerator is under control, we call it, under control, right? It's not getting big and it's not getting small. That's why this series will be convergent. The question is, how do you say that, right? Right. So this is our AN, and it's under control means it's going to be n squared plus 1 sine n. The limit of sine n doesn't exist, but this is going to be 1 squared plus 1 n squared plus 1. It's going to be less than 2 over n squared. So that's the BN. According to P series, this is convergent. Okay, so this BN is convergent by the P series test. Okay, so this implies this is convergent. Okay. By the direct comparison test. We don't have a direct comparison test. Just comparison test. Limited comparison test. Sometimes it's harder to make a direct comparison. Then you have to use a limited comparison. You can use a limited comparison, but for this one, I'm not sure you can use a limit comparison because sometimes the limit doesn't exist. Yes.
Those cosines, then how change?
No change. Yeah. If it's cosine, the cosine is also under control, right? This is the value of cosine. The square is between 0 and 1, right? But if you use a limit comparison test, that would be issue. If you limit the comparisons, I see, and this is a good example. You cannot use a limit comparison test. So here is n squared plus 1, and sine n squared plus 1, and here's n squared over 2. So after you simplify, you will get n squared over 2, n squared plus 1, no problem. But how do you handle this? This approach is to 1/2. Okay? But this one does not exist. So if you look at the limit, this limit does not exist. It's hard. You cannot use the limit comparison test. Okay? We cannot use the limit comparison test. Yeah, because the limit has no limit. Right, and determine whether this is a condition convergent or a divergent or absolute convergent. Okay. And my question is whether it's condition convergent and how do you prove it? So my suggestion is to look at the absolute convergence first, because what happens if you have absolute convergence, then you stop there. You don't need to do anything else. If you look at the condition convergence, just look at whether it's convergent. You are by alternative series. Yes, it's convergent. Then what? Can you still say that they converge absolute convergent or not? Then you have to continue work on another series, right? Without the negative sign. That's you have to double your root in case it is only condition. No. Yeah, condition convergent. So we begin with absolute convergence first. Okay. In general. Okay. So you look at this. Okay, and clearly this is going to be divergent. Why it's divergent? Because n equals, and this is actually is going to be as a bn. Okay, so you look at this two, and then they're almost the same. Okay, so that since bn is divergent, okay, why it's divergent? By the p-series test. Okay, we already used the integral test to verify this. Okay, p is 1/2, which is less than 1. This implies n is divergent. Now, so let's go back to this problem. Okay. Is it convergent? Yes, it's convergent. But you have to figure out, yeah, this is let's call the Cn. I use a different notation. So Cn must going down and approach 0. And approach 0 is obvious. Why it's decreasing? Then you have to use the derivative to find out, right? F of x equals x plus 1 square x. So when you differentiate, you get x plus 1 square, derivative square root, this is this, and minus square x times the derivative denominator, which is 1. Right? So you will get an x plus 1 minus 2x, which is 1 minus x squared, right? And this is clearly less than 0 for x greater than 1. So it's decreasing. Okay, so this concludes that, and this also implies that's decreasing. Okay, then, so therefore the series is convergent by alternating series test. Okay, then if it's not absolute convergent, it's convergent, so it's conditional convergent. Right. All right, so please do this problem. Are you done? Huh? You think it's divergent? You thought, or can you prove? You can get A plus. It's difficult to get A plus on this course right now. I look at all the students' performance. Probably nobody. Okay. So this is a divergent. And how do you prove it? And think about it. If I tell you it's divergent, right? I don't know how do you prove it's convergent. First of all, if you think this is a Bn, the Bn is negative for large n because of 4 minus n. I have to switch the order, right? So n minus 4 over n plus 4. This is not going to be convergent to 0. That's the main reason. You see, if you apply the alternating series, you have to prove it's decreasing. Not only that, you have to prove it's decreasing to 0. Remember, that's 2 conditions to be met. You probably only prove it's decreasing, right? If it's decreasing, that's not enough. Okay. Yes, it's decreasing maybe. And I didn't even check that. Okay. So clearly, 4 minus n, 4 plus n, this approaches negative y as n approaches infinity. Okay. Therefore, but there's a sign in front that make this limit doesn't exist. Does not exist. Of course, it's not going to be 0. Therefore, it is diverged by the nth term test. Okay. So you should list all the possible, all the tests, okay, possible tests you can use, and ask yourself, did I use this one? Did I use that one? You find out you only use 1/3 of the tests, and okay, for all the problems of final exams, and I think you're in trouble. You probably only get 1/3 of them correct. Okay, something only use one single one, ratio test. Okay, no matter what it is, ratio test. Yeah, we do have a problem. This is the only place you probably have to use the load test or a ratio test. Yeah, let's look at. Okay. So this is going to be n. Yeah, just it's 1 over n plus 3. Okay, something like that. All right. So you have to determine the radius convergence, and so this is a whole term. It's an. So when you start with, you have to put the absolute value. Okay, and after you simplify, ignore the negative sign. Okay, after you simplify, you will get here's n plus 4 x to the n plus here, and this is a okay. So and the limit is going to be okay as n approaches infinity. So clearly, it is absolutely convergent if this is a less than 1. And it is divergent if absolute x is greater than 1, right? So the radius of convergence clearly is 1. The question is, how about the end point, right? You want to find the interval of convergence. The end point, when x equals 1, this will be -1, right? It's going to be n plus 1. And this clearly is convergent, okay? N plus 3. All right. Now, when x equals -1, and this will be just 1 of n plus 3. So this is divergent. Okay, so that means at the one end point it's convergent, at the other point it's divergent. So the interval of convergence is going to be from -1 to +1. And including the positive. For math 261, I'm not going to teach 261, but someday if you want to take this 261, I record all of my videos for that too. Like in case you need it, just write it to me. Okay. So this is I think that's enough, maybe, right? Do you have any other questions now? One more. Okay, good. So f of x is going to be natural log of x, right? 4 minus x. And find the Taylor series of 1, right? Right, well, the same idea. Okay. First of all, I needed to know the power series representation for natural log of x. Okay. So for the natural log of x, we needed to recall this. Do you still remember this? No idea. You have to memorize it. Okay. So it's going to be negative. I believe that. That is going to be nx to the power n. Okay. The reason I got this is because I know this is 1 of x, right? Okay. And I integrate on both sides. When I integrate, I get a negative nature like a 1 minus x, okay? Because the antiderivative is here. So here, this, okay? Because I put a negative sign to the other side, I get that. N start from 1. You can express the n start from 1. Right? So that's why, technically, I only memorize one geometry series. I can get another one. Other one. So this is a, yeah, you have to know this. Okay? Otherwise, you cannot do the problem. All right. So now you let u to be x minus 1. So x is going to be u plus 1. This function is going to be written as 4 minus u plus 1. All right. So you can simplify. It's going to be 3 minus u. It's not 1 minus u, right? So I have to take 3 out. So I have it separate, it's constant. Then negative sign to the power n. Done. All right, so that's it. So find the Taylor series, do not find the derivatives. I look at the test 2 you took. Majority of the students just go ahead and find the Taylor series, find Taylor series. Sounds like I never listen to my lecture notes. Just look at the book. The book tells you like that, okay? Because in the book, they're going to use a formula to derive the Taylor series for sine, cosine, power series representation, right? But we already have that. We can use it, okay? You don't need to redo the job, okay?